peach, plum, pear, and I added const fruit 0, 1, 2, 3, pineapple. Oops, sorry, not const fruit. Fruit 3 is pineapple. Okay. And no problem. So now I can console log fruit. Pineapple's there. But here's the really interesting thing. What if I do this? What if I switch it from the 3rd index to the 10th index? Is my array, do I have an array of size 10? Or this would be 11, right? This says 10, which means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 11th element. Can I do this?
Yeah.
Okay, so if I do this, if I put pineapple, if this will put pineapple way down, whoa, that's not what I expected. Way down here.
Yeah.
What happens with all these?
Undefined. Undefined.
No.
Let's find out. We'll print out fruit, we'll see what's in there. 7 empty items. This is, okay, so again, this is Node.js being helpful. Really, if I look at these items, for example, if I look at fruit 6, undefined.
Undefined.
So if you would, so what this is saying is, if you attempt to access a variable that doesn't exist,
Undefined.
sorry, access an element in the array that doesn't exist, the element is undefined. Even, so you can do this, and it will put pineapple way down there. Along the way though, you could potentially encounter elements that are undefined. Okay. Any questions so far? So we can declare an array. We can manually add elements to an array. We can get the value back. So we can add and get, set and get using the index. Let's look at a couple of array properties. Okay, so arrays have some information. We can ask the array some information about itself. And one of the most important pieces of information that we can ask about itself is, how long are you? How many elements do you have inside? And so I'll get rid of this. Get rid of this. We'll work with the same array here. And we'll say console.log fruit, the array, dot length. And array.length, fruit.length, right? Fruit.length. Or array.length. Same thing. Okay. How many elements do you have inside? 3. So now that we know how long the array is, what would be a really easy way for me to add an element to the end of the array using that length property? See if you guys can make this leap. Okay, so I have a length property. It tells me how long, gives me a number. Using this number and this sort of fruit something equals pineapple. How can I use length, this information here, to set this? So Saria is saying take this, stick it in there, and boom. I got pineapple. Let's take a look.
All three would be changed.
Let's take a look.
I was about to say that plus one and plus there.
Okay. So why did it change? Why did it add to the end? If it's length 3, why did it add to the end and not overwrite pair?
Because 0, 1, 2.
Because 0, 1, 2, right? So we're getting, here's a big kind of shift that we have to constantly be making back and forth. The length of the array is reported as the actual amount of elements in it, whereas the index is, but that's starting at 1, right? 1, 2, 3 things. There are 3 things. It is of length 3. But when we count indexes, it is 0, 1, 2. So that's this constant shift that we have to make back and forth. Okay? So if we wanted to add elements to the end of the array, we can do fruit.length, pineapple. So here, in between these braces, these square brackets, we don't have to put a number. We just have to put something that evaluates to a number. So fruit.length in itself is not a number, but it evaluates to the number. And so we can do this over and over and over again. And each time we do this, the length of fruit increases. And so we end up with peach, plum, pear, pineapple, 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 pineapple.
The last
That
one.
in a order.
Okay? Cool? But I like your idea. There are some loops that are just perfect for arrays. Perfect for arrays. Okay, and that one is the for loop. Now, well, it is and it isn't. If you wanted to build an array filled with pineapples, 100 pineapples, you don't have to do pineapple, pineapple, pineapple 100 times. Instead, you can create an empty array and you can loop through it with your favorite for loop. Starting at 0, because that's where we start arrays. And we want to fill it with 100 pineapples, so 0 to 99 elements, plus plus, fruit, x. It starts at 0, then it goes to 1, then it goes to 2. It evaluates to a number, equals pineapple. Brilliant. And now we have 100 pineapples. Okay? So we're using all these things now. Okay, for loops are really good to run when we know how long we want them to run, but they're also really good at running when we don't know how long it is to necessarily run, but when we have an array. So So now we have an array of 100 pineapples. Let's ask the for loop to loop through the array until it gets to the end of all the pineapples. Okay, so let's create a new for loop. We have fruit, an array of fruit that contains many pineapples, 100. But let's pretend we don't know. Because oftentimes in programming, things are happening and it's so dynamic, right? We're taking in numbers. I don't know how many sides the dice has. Something more than 3. And so we kind of have to write our code to be ready for anything, which is why we write a while loop, because we don't know how long it's going to take. We don't know how big the array of fruit is going to be. So let's write a for loop that will loop through it until it's at the end. So we know we want to start at 0 because that's where we start arrays. Right? That's where our indexes start. But how long is this loop going to last? How many times are we going to go through this loop? I want to print out every element in that array, and I don't know how long, and I don't know as the programmer how long it's going to be, but I have the tools already to figure it out. What is going to be my condition for stopping? Yeah, so as long as x is less than fruit.length, but we got to do that conversion of like indexes versus length. Fruit.length minus 1. Less than or equal to. Or less than fruit.length. X plus plus. So we're starting at 0. We're going to almost the end of the, this will be 99. Sorry, this will be 100. There's 100 pineapples. But we don't want to use 100. We want to go 0 to 99 because that's 100. X plus plus. Console.log fruit x. And this will print out all the 100 pineapples. Or we can change them. Or we can do whatever we want. This loops through all of them. Okay? Are we okay here? Okay. So, for loops are intimately tied with arrays. So intimately tied, in fact, they have another way for us to go through this array, a new loop. And it's called the for of loop. It's very easy. It looks like this. For, and then we declare a variable that we're going to put our element of the array into. Let, whatever you want to call it, of. You'll often see, usually arrays are plural. We use variable names that are plural because they contain many things. And you'll often see this one be singular. Now, console.log fruit. And we can access each element individually.
This is the for each version of JavaScript, more or less.
No, there's another. That's separate. We're going to look at for each tomorrow. There's another.
Oh,
way. There's like, okay, so your fundamental loops are while and for. while loops and for loops. This other loop and some other loops. So your while and your for loops are very generic. While works on a condition, for works on a number. This only works for arrays.
Okay.
Yeah. And then the one that we're going to look at tomorrow
Oh.
only it works on arrays and things that are like arrays.
Okay.
Okay, but the for loop, your general for loop and your general while loop, they're generic. It doesn't matter. You can use them anytime. This only works on arrays. So fruit of fruits, or x of fruits, or element of fruits, or whatever you want to call it, right? You make up the variable, and then you can access that variable, and this variable is the element itself. Okay?
You can call it whatever you want.
You can call it's a variable, so you can call it whatever you want, right? I can call this whatever I want too. For x of y. Whoops, for x of y. Right? It's just a placeholder for you. So the loop will take each of these. So fruits is the whole thing. This loop will take the first one, put it in there, then you do whatever you want with it. Then go to the next one, put it in there, then you do whatever you want with it. Right? And each time through the loops, it replaces this variable with the next element in it. So then you access, you go over the array, you step over it one at a time.
Okay, so that for is connected to the const. If you put it in there.
Yeah, whatever, this must be an array. I can actually stick this right in here if I wanted to. So it's going to take each element, put it in here, run this block of code. Then it's going to go to the next element, put it in here, run this block of code. You only get the element, you don't get the index. Which you might think is okay for now, but you're going to quickly realize that sometimes you want the index. And you have no way of knowing the index here. I don't know what index fruit is at in the array. It doesn't tell me. But if I used a for loop, all I get is the index, but from the index I can get the element. Right? So this is easier for writing, less thinking too, but you don't get the same flexibility. And so it's a trade-off. Sometimes it's good, sometimes it's bad. Depends really on your what are you trying to do with this stuff. If you're just trying to print it out, no problem. But if I said and print out the index that is at, you couldn't do that. Couple other things. Multi-dimensional arrays. Okay, sounds very science fiction-y. All this is an array of arrays. So, for example, I have a matrix. Matrix are arrays and arrays, but I'm not going to call it matrix. I'm going to call it FF7 characters. And we're going to use, in this array of arrays, look at my weird syntax already, right? I'm starting the array here, and I'm ending the array here. I'm using them as parentheses. And I'm going to make 3 arrays in here. And the first element of the first array will be Tifa. Okay, I have an array of arrays. So what I end up with, and actually it shouldn't be like that, it should be like that. What I end up with is this super weird syntax of what is the first element of my array? Tifa Lockhart. But that in itself is an array. So how do I access the first element? Brackets, 0, because that's the index. How do I access, now this in itself is an array. How do I access the first element of this array?
Another bracket inside.
Not inside, but beside it, right? Because this evaluates to an array, this array. So you end up with this. And if you take this, if you actually took this to your console, actually if I just ran it here, it wouldn't do anything because I need to console log it. But if I wrap this in console.log, it will print Tifa. So that your array, your first array evaluates to an array, and then you're putting this on that. So you end up with this weird syntax, and it can go as deep as you want. Array in an array in an array in an array in an array. Why would you do that? I don't have a good reason for why you would do that right now. But sometimes it's just the case, right? And to loop through this, you would need nested loops. Either nested for loops or nested for of loops. So if I wanted to loop through this, I would need an outer loop, let x equal 0, x less than ff7 characters, x plus plus. So that'll get me through the outer loop. So I hit each one of these, but then I also have to go through each of those on the inside, so then I need another loop. Let y equals 0, y less than x dot length. Oh, ff7 characters dot length. Because x is this inside array. And actually, no, sorry, but it's ff7 characters, x is the inner array. Yeah, okay, so this is I'll sit on this for a second. Okay, I won't speed through. Plus plus. Console.log. F7 characters, x, y. So we need to sit here for a second, because this is a tricky one. Luckily, you won't be doing this a lot. Okay, I can't say with any certainty that you'll never do this in this course, but you probably won't do it very much. So, this line 9 to 13, that is bringing us through the outer loop. Each of these, line 4 is an element, line 5 is an element, line 6 is an element. Right? Normal loop, characters dot length. Array dot length. Our inner one, remember, this piece here evaluates to an array. Because before we were saying, remember when we said this prints out Tifa? And we said, well, this evaluates to an array, Tifa Lockhart. And so that is the same thing here. It's just the x is starting at 0 and going to 1 and going to 2, and then it stops because we hit x from the outside is less than length, right? And then that's done for the inner loop, and we start again on the outer loop. So x is that 0, 1, 2, 0, 1, 2, 0, 1, 2. And so this is something that you'll need to, like, it might be worth sitting and, there should be a nested loop example, 100% is a nested loop example in your arrays. I'll post this. It's kind of just one of those things that you have to get used to. Hmm? Yep. I'll post it in the notes that I don't post. I'll post it in the notes for you, so you have a copy of it. So it's worth just sitting here for a moment till you really understand it. There's no trick, but it's definitely like a little bit of harder logic to wrap your head around. So sometimes it takes 5 or 10 minutes of staring at it, but once you it should just click. Okay? Once you get it, it's not going to disappear. It always is tricky. Nested loops are always tricky for understanding, especially nested loops where the inner loop is using variables and like things from the outer loop. Okay, so I'll post this, don't worry, but I can't sit on this for much longer.
Sorry, what will that print out? X, Y.
Well, X is this, and then this, and then this. Y is this or this, this or this, this or this.
So X is rows and Y is column.
Yeah. X is rows, and Y is column. So this is row 0 to start, column 0. Row 0, column 1. Row 0.
So you can't put a Y without the X. Oh, it becomes an X.
What if you wrote code, say somewhere else, and you used X and Y, and now you can't use X and Y?
They only exist, the nice thing about using let here is remember let is block scoped, it only exists here.
And the console just knows that when you say X, you mean
I mean this X.
horizontal, and
Yep.
Y means vertical?
Nope.
Or is that-
No, it's X is like if I said this and I showed you if I said this which of these is represented by this? How about this? None. Undefined. That doesn't exist. Right? But how about this? Here. So we know that when we go through loops, X and Y are starting off at 0. So the first time through these loops, it's 0, 0. And so it doesn't know row and column, it knows 0, 0. Then the second time through the loop, it's 0, 1. And then, because it's looking 0 dot length, right? What is characters, what is this dot length? 2. So Y can never get to 2. It gets to 1. It starts at 0. Then it gets to 1. And then it does once it hits 2, this fails. And it loops back up to here. And it goes now to the next one. So now X is 1. And we repeat. 1, 0, 1, 1. Same thing, can't go any further. 2, 0. 2, 1. This fails, now this fails, and we did it all. We're all done. Okay. Make sense?
So technically, the Tifa and Lockhart, they're not actually, it's not actually a column.
It's not actually a column. and because we can put as many arrays inside arrays as we want, we call them multi-dimensional arrays instead of two-dimensional arrays. There can be as many dimensions as we want, right? Arrays and arrays and arrays and arrays and arrays and arrays. And for every nesting you do, you have to add another loop. But again, it's uncommon, but it's uncommon.
The up by one makes sense though, like when I think of it as like, that zero is actually a one and it's going up by one.
Yeah,
And then it gets stuck in that for loop and it goes through all of the ones.
right.
And then it goes back and then it's two.
Yeah, and once you get there, once you get to that understanding, it's like, oh yeah, okay, that makes sense. It's not a trick, it's just sometimes the logic can be difficult to walk yourself through. And that's okay. Couple of other, yeah, go ahead.
Sorry. In the reading material, it says something about like adding extra comma at the last array.
Okay.
I didn't understand why.
Okay, so good way to catch that, and that's something I was actually just going to talk about. This is called a dangling comma. And it looks really weird, right? Because it's like, all right, and the next one is, there is no next one, right? In Java and other languages, this would be an error. But in JavaScript, this is, you can do it or you don't need to. I want you to get into the habit of adding this. Here's the reason why. I come here, I need to make a quick update. I'm like, oh, I need to add 2 more things here. I'm just gonna do that. And change these, Okay, and I don't know where's the last images. Okay, and I go to run this, and boom, it doesn't work. Why? Because I missed a comma. Oh, that's annoying. And so we've gotten to the habit of always putting commas in, so then when we need to add more rows, every row or every piece, every element looks the same, even the last element. And so adding additional elements is really easy, and we don't ever have to worry about that error. So that's like your dangling comma. What's that? Barrett Wall, that's right. Okay. Last but not least, this is one of my favorite parts. A equals 5, B equals A equals 10, console log B prints out.
5.
Who said 10?
Oh.
Here's why. And we know this. We don't know why, but we learned this. First day of JavaScript. The variables that we create actually exist inside our computer memory. That's where variables go. That's why we need computer memory. Okay? If you haven't made that connection yet, then congratulations. Now you know why we need computer memory. Right? Like, we're gonna make sense of everything that's in your, by the time you're done this course, all the stuff that's in your computer is gonna make sense. And this is RAM, not hard drive. Hard drive is long-term, RAM is short-term while the program is running. So while your program is running, a variable is created, A, and the value is 5. And then the next line says b equals a. Okay. New variable, b. Whatever the value of a was, that's also the value of b. It's not this. No. It's this. And so when we're changing a, right? This makes sense? I'm not also changing b, I'm changing the value that's in a. I made a copy. I make a copy. And this sort of concept, this is called pass by or like we use it by value. We pass it by a value. We create a new copy. When I change a, I destroyed 5. You saw me erase it. I destroyed it. And I created I input a new value. This works for primitives. This is a defining feature of primitive data types. And we haven't fully discussed what a primitive data type is, but let me tell you really quick. Things that we know are primitive data types. There's others, but these are the main ones that you're going to be using. So, if I were to do the same thing with a string, you would get the same result. And if you don't believe me, we can just try it out. Okay, I changed A, but that doesn't change B. Just because I changed A, that doesn't change B. Strings are the same. So numbers, booleans, and strings, they all do this type of thing. Arrays are different. This is how arrays work. So let's say, let's make up some new variable names. C. And D. So if I did the same thing with an array, C equals array, this 1, 2, 3. Let D equals C, 0 equals high, console log D. Because they are referring to the array by reference. So when I say D is equal to C, I'm not creating a copy of this array. It is simply saying that spot in memory that you stored that array in, I am also going to refer to that same spot in memory. So that array lives in memory, and the variables are just pointers to that spot in memory. They're just pointing at it. They don't actually contain the value of it. They're pointing to it. So there's only one copy of that array here, in this case, the way we set it up here. There's only one copy. C and D both point to that one copy. That's like saying, this is your Mac, this is Saria's computer. Both of those things are true, right? And they're both referring to the same thing, right? So that's this. They're both the same thing. They're both referring to the same thing. So I can say, I think I'm gonna try this. I'm sorry, I don't really know how to spell your name. And so, is that incorrect?
Yeah, it's
Okay.
okay. I think it's
And oh, sorry. Right? Your computer is your Mac, and your Mac is this array. And if I change this array, it's changed. If I install something on that computer, it's on both of these because these are just referring. They're just different words for your same computer. But if I did this with a number, a Boolean, or a string, it actually creates a new computer.
So as long as it's not primitive.
As long as it's not a
Okay,
primitive.
okay.
Yeah. As long as it's not a primitive. So if I do that with any other type of any other data type, it refers to the same thing. Or any other data type, it's something different. Primitive data, non-primitive data types refer to the same thing. And so that's really important to understand because if you go about changing arrays in places, you need to understand that anything else pointing to that array could also be impacted. You will see this, okay? This might be like really confusing right now, but once you start using them, this little bit of information will come back to haunt you a little bit. Like not haunt you, but if you didn't know it, you would never understand why is my array not what I expect it to be. And the answer is often, it's because you changed it somewhere else and you didn't realize the impact of that change. We don't have that problem with these. And so the types of problems that you would encounter with these primitive data, or with arrays, you wouldn't have encountered with these primitive data types. Okay, and as you start doing some exercises, you will see this happen. Okay, you will encounter this. So my recommendation, do not change an array while you are looping over it. Do not change an array, do not modify an array while you are in the process of looping over it. You will get unexpected results. Okay? Most of the time, unless you really know what you're doing.
Are you
It's
saying
simply
do not,
a recommendation.
Are you saying do not put arrays in loops?
No, I'm not saying that. I'm saying if you're looping over an array and you're doing something with the values of that array, it's okay to modify it. You don't want to change the length necessarily because that loop is oftentimes running based on the length. And if you start changing the length, your loop is going to start changing on you.
Okay.
Right? So you can modify the individual elements inside of it, but just be careful, it gets dangerous when you start playing with the length.
Okay.
Because if that length is becoming variable suddenly, you go into the loop with this idea, oh, this loop will run X times based on the length of the array. Oh, but now inside the loop, you're changing that length. And so like, whoa, that might not work out in your best interest. We're gonna stay on arrays for 2 days. So we're coming back to arrays tomorrow. But tomorrow I'm going to introduce you to a bunch of new stuff, and that's going to coincide with a lot of the stuff we talked about on Friday, which is functional expressions, inline functional expressions, and callbacks. So I'm going to introduce to you the reason why we would ever want to do that crazy thing where we pass a function into a function, and it'll make sense to you. So today, for arrays, I have some practice. So this is, okay, so this is, this isn't passed by reference. What I mean by pass by reference really is it comes down to functions. And this is where pass by reference matters. So this is where this is where it comes from, pass by reference. If I pass my array in to here, my function, and I make a change to that array inside the function, it reflects outside this function. This would not happen with the number, for example. So watch. So I pass the array in as a parameter. So the reference, I'm passing it by reference, gets stored in here. It makes a change to that array that's in memory and changes this to 10. And then when I print it out, that's what I would get. But if I did this with a number, and then I said that, when I pass it into the function 5, it makes a copy of 5. And so R, even though I'm making it now 10, it's still 5. So this is passed by value. This is by value. This is by reference. I'm passing in a reference to the array versus I'm passing in a value directly. That's where that concept comes from. I'll find out the actual concept of how this exists within memory, so I can give you that name.
Is that because you use counts and not length?
Irrelevant. That has no impact on it. Whether or not you use const or let, still the same result. Yeah. So a couple pretty crazy things that we learned today. The nice thing is, for the most part, 10%, so 90%, most of the hardest things that we did today is going to only be about 10% of the stuff that you ever do. Very limited amount. Of all of the things that we did today, the hardest stuff you won't see very often. It's usually the easiest stuff that you'll see. Making an array, looping over an array, adding stuff to an array, getting the value from an array. That's mostly what you'll do. Occasionally, this will rear its ugly head. Nested loops will rear its ugly head. Pretty infrequently.
Is it because they're difficult to write?
No, it's because there's not a lot of use cases for it. They're very specialized. I can come up with examples coming out of my butt for all this simple stuff. Because you do it all the time. But the other stuff, it's really hard to come up with a use case for it. And so it's really hard to come up with examples that are meaningful. Because we just don't do it that often. Maybe if you're getting into very specialized territory, but I was never in there. And as a junior developer, you're not going to be there either. Okay. Let's take a break. Come back. I'll answer any questions. We'll go over the exercise, and then you'll have an hour to do it. You can come ask me a question.